Let's get a bit of soap making terminology out of the way in this tutorial. In every soap making video, you'll hear a crafter say that they're working with trace. This is a description of the change your soap batter takes as it's becoming saponified. The first part of this lesson is going to show you what it looks like to go through the trace process when you're working with your soap recipe. In the second part of the video, I'll cover the gel phase of your cold process soap and why you might want to insulate your soap. Then I'll show you a basic troubleshooting tip if you make a soap that only partially gels when you cut it open. There's usually an easy way to fix this. And once we cover these two topics, we'll get right back into our recipes. But first, if you want to catch all 10 parts of this tutorial in cold process soap making, don't forget to hit the subscribe button and catch the full playlist, which includes 9 recipes, all of which are designed for cold process soap making from the heaviest trace to the thinnest. Yes, I know I said 8 recipes in the first video, but I slipped one more in lesson 3 that seemed to fit the topic, so now there are 9. All of the videos in this tutorial come with recipes that you can print and keep. You can find these either in the membership area at thermalmermaid.com, where you can find 10 full lessons and dozens more tutorials and video recipes, or you can grab them easily over in the Facebook group at Thermal Mermaid Soap and Bath Making. Now that that's out of the way, let's cover trace. At the moment you combine the oil and the lye water, a chemical change begins and all the molecules you've just poured into your bowl begin to find a partner. Mixing the batter makes this happen faster. It takes just a few minutes for this to happen, and at first your batter will emulsify. That is, it'll blend together and look smooth to the eye, but the chemical is still bonding. As you continue to mix, you'll notice a change occur. The liquid will start to look like a pancake batter and become thick. When you pull the batter out of the bowl, the batter will follow with a texture like pudding, and you can trace a line across the surface. At this point, your batter has come to trace. If you continue to mix with your stick blender, the batter will continue to thicken until it forms soft peaks. Now, you don't want the batter to get so stiff that you can't transfer it into the mold. In fact, you want to control the trace as much as possible, depending on how much time you need to work with this recipe. If you need to mix several colors, you don't want your batter to become too thick too quickly. One of the biggest challenges in making cold process soap when you're beginning is learning how to control the trace so that you can get a specific design into your project. If the trace becomes too thick, you can't get those wispy swirls into your bar. So how do we do this? Number 1, the first thing you need to learn about controlling your soap batter is the temperature. The warmer your oils and lye solution, the thicker your soap batter will become more quickly. To keep the trace thin, make sure that you're working at or near room temperature, and make sure that both of the liquids are within 15 degrees of each other. This will keep the molecules from shocking each other, and it will keep the chemical reaction more calm when the molecules are trying to bond. Number 2, use enough water in your recipe. If the temperature is fine, but the batter is still thick, you might want to increase the amount of water in your recipe to loosen up the liquids. If your recipe calls for 25% water, well, then try 35%. Number 3, know your fragrance oils. Sometimes the batter will accelerate as soon as you add the fragrance. If your fragrance oil is known to accelerate trace, there won't be anything you can do but work quickly. Try to use fragrances that are known to behave in your soap if you need a light trace. And finally, number 4, the oils you use in your recipe will make all the difference in the world. Some soap recipes are known to take forever to come to trace, while other recipes will become thick in just a few minutes. Oils that are high in fatty acids will thicken more quickly. Otherwise, your hard oils will come to trace faster. Thick trace oils are ones like rice bran oil, palm oil, and shortening, shea butter and cocoa butter, and castor oil. Oils that will give you a slow trace are olive oil, vegetable oil, sweet almond oil, avocado oil, and lard. In the recipes here in Lesson 2, we will be working with formulas that will start off giving us a thick trace and end with recipes that give us a more thin trace. Part 2. Let's talk about the gel process. The gelling process is another term that you hear that many soap makers use. This is part of the saponification process when the soap goes through heating. Usually this happens around 170 to 180 degrees. When heat is trapped in the soap, it'll go through a gel phase. The heat will produce a soap with a little bit of a different color, and that change can even go so far as to give it a translucent jello look. The gel phase saponifies your bar faster and shortens the curing time. During the process, the center of the batter will generate more heat than the outside of the batter in your mold, and this will lead to a different rate of gelling within the same bar. If the heat process is interrupted, it can result in a color that morphs unevenly. This is purely cosmetic and it does not affect the quality of the soap. Here's an example of a bar that got hotter on the inside than on the outside, and the gel process happened only on the inside. This bar went through a partial gelling process. Now the pros of gelling are that you might get a look that you like better, it will cure faster, and it can be used sooner, and that means it will last longer in the shower. Now if you want your soap to gel, you can try insulating it while it's setting up during the first 24 hours by placing it on a rubber mat and wrapping a kitchen towel around the mold. You can even cover the top in plastic wrap. One warning though, soap expands when it gets too hot, and if it gets too hot too fast, it might push its way out of the mold, so be sure to keep an eye on it for overheating. Now you do not have to encourage a gel phase while your soap is setting. You can put your soap in a low heat environment, and you can even put your soap in the refrigerator to stop the gel phase completely. The soap will still saponify, but just a little more slowly. The pros of preventing the gel phase are that it's easier to control the outcome of the project, and the colors are more bright and vibrant, and the fragrance are more likely to remain strong. So what happens if you spend all your time working hard on a project only to cut it open and discover a big ring inside the soap messing up the design? Sometimes a partially gelled soap ruins the look you wanted, so let's run through a popular little fix for this mistake. If the soap looks too offensive, we can use a version of the CPOP method to correct the look. This stands for Cold Process Oven Process Soap. Stand the bars on a cookie sheet with a silicone mat or a paper towel lining on the surface of the cookie sheet. Turn your oven on warm and allow it to preheat for a little while. Make sure to turn the oven off and then place the soap tray in the oven for 5 minutes. The heat will finish the gel process and your soap will have a look that becomes more uniform. You may have to try this twice, but just make sure you keep an eye on your soap so that it doesn't melt or nothing funny or unexpected happens to it. Now that we've covered these basic beginner cold process terms, follow me over to part 3 of this tutorial where I'm going to give you a recipe for you to get that nice stark white bar of soap.